Hello. If you look at your syllabus, this is the hard copy of our syllabus, which we discussed long time ago at the beginning of our semester. You probably can see right here the information about last day of class and about day of your final. So last day of our lectures of our class is May 15th, which means it will happen on this week on coming Friday. We have just few absolutely topic. Definitely we will finish all required material. And our final is on May 20th from 11:10 a.m. up to 1:40 p.m. It is equivalent of 3 academic hours. I would like to make a comment about the test which I had with you on the previous week, which I graded as I promised, and yesterday at quite late evening, I sent to all my students in your class the results of that test, your grade, replying to your emails with your tests. What can I say about this test? I already discussed all problems, all details about all problems which we had in this test, so I'm not going to talk about that. But I would like to admit one thing, because now I have some kind of opinion about how some people were prepared to take this test. First of all, I can proudly say that the highest grade in this class is 100%, and actually 2 people got 100% as a grade. Quite many people got grades 80 or higher. But unfortunately, the lowest grade in this class is very low. And what I observed here, that people who got quite low and attractive grades, in my opinion, they were practically unprepared for this test. This is very sad. People need to be a little bit more responsible. Specifically, it was a trigonometry. It was a not brand new material. Only last problems were last problems were about new material, and people need to be a little bit more serious about trigonometry. What I saw on some papers, it means that if before the calculus class they took trigonometry class, they practically did not learn anything in that class. I did not have so much time in this class, and actually I'm not obligated to do that, to reteach trigonometry, and I had quite serious review of trigonometry in your class, because quite many actually colleagues of mine actually even skip review of trigonometry, saying that they just passed that class, they need to remember everything what they learned in the previous class. I did not assume that, and I had quite serious review of trigonometry. Definitely trigonometry will be included in your final as well. Think about that, please. What I'm going to do right now, I will be solving problems from chapter 11. Some topics are not absolutely new for you. Some, like, let's say, limits, how to provide a detailed analysis of the behavior of the function. Maybe you did not do that, and definitely there will be details which will be new for you, but you, again, you covered this material, part at least of this material, in your Math 120 course, which was the course of intermediate algebra. Please be serious about everything what you learned in previous classes, because we cannot erase this from our assumption that if you pass these classes with passing grade, you need to demonstrate skills which you learned in these previous classes. Think about that. I think that it is a very fair statement. What I'm going to do right now, before I start reading your names, I will give you some problems to work with. And after that, we'll check your attendance. And after that, we'll together, we'll be solving problems. Can you please be on page number 439 from the textbook? This here, we have exercises and problems from section 11.1. And I would like to offer you some problems. Let me write them also on my piece of paper. So please, let's say again, it is page number 439. 439. Can you please start working with problems number S2, S4, and S6, S2, S4, S6. S2, S4, S6. And let me check our attendance for today, and I will go from there. Okay. Andrew, Tima, I don't know why I saw Tima's name, but I don't see that right now on my screen. Okay, because I have names of students who participate. Okay, Lorraine?
Here.
Yes. Lynn?
Here.
Juanita? Yuran?
Here.
Gabriel? Gabriel? Okay, so Divina?
Here.
Chantal?
Here.
Okay, so Gongsi?
Here.
Kyle?
Here.
Matthew?
Here.
Julian?
Here.
Nathan?
Here.
Alejandro?
Here.
Thank you. Okay. So let's start solving these problems. You are absolutely welcome to ask as many questions as you need. I simplify the expression, and let's see what we have in S2. Parenthesis 3x square root of x cubed. Everything in parentheses should be raised to the second power. This is that problem. 3x square root of x cubed should be, this product should be raised to the second power. What I discovered here inside of parentheses, there was a coefficient 3 multiplied by x in the first power and multiplied by square root of x cubed. But a radicand under that square root also has a power which has base x. This y, first step, which I really recommend you to take, instead of raising each component right away, let's say to that second power, to simplify that expression which you have inside of parentheses. Definitely, we are applying here, and we will be applying here a formula for the power of the product. So I will open parentheses, and it will be 3x times, can I, instead of square root of x cubed, write x to the 3/2?
Yes.
Okay, and square. Here we have side by side 2 powers of x with different exponents. First exponent is 1, second exponent is 3/2. What can we do if we face the product of 2 powers with matching bases? We add exponents, keeping the same base. So again, exponents were 1 and 3/2. If we add 1 and 3/2, what do you get? Guys, if you are adding 2 numbers, 1 and 3/2, what would be their sum?
5/2.
I could not hear, unfortunately. Can you repeat a little bit louder?
Is it 5/2?
Definitely, it is 5/2. If you like to do that in not just adding like 1 with the fraction 3/2, 3/2, is it 1 and 1/2? 1 plus
Yes.
1 and 1/2. Is it 2 and 1/2? Other words, it is actually 3/2.
Yeah.
5/2.
Yes.
If you can do that in that way. I would probably do that just simply 1 plus 3/2, but it's okay. It is just other way to do that. Now we are left in parentheses with monomial. Yeah, it is a monomial, which we have to raise to the second power. This monomial has a coefficient equal to 3, and the other part is x to the 5/2. Each should be raised to that power. So it will be 3 square, because it's 3 to the first power raised to the second, x to the 5/2 raised to the second power. It is x to the 5/2 times 2. If you multiply 5/2 by 2, is it just x to the 5th power?
Yes.
But I would not keep this as an answer. I definitely will convert, because we have here 3 squared to the 9. So it will be 9x to the 5th power. Definitely, some steps can be skipped. I showed all steps here because I did not want to confuse anyone when we were solving this problem. So, do you have questions about this problem?
No.
No.
Can we move to S4?
Yes.
Yes.
Yeah.
And here we have a product. We have here 3 components. Let's write this down first, and after that we will discuss. So what do we have here in parentheses? 5w to the 1/2 multiplied by the last parenthesis, in which we have 2w to the, is it 1/3, guys? Because it is so.
Yes.
Thank
Yes.
you. Thank you for your help. This what we have. So what do we have here? This is definitely a product. Definitely it has, we have here numerical factors, which are 7, 5, and 2. 5 and 2 are coefficients of 2 monomials. What do we do here? We first will be multiplying actually these numbers. You can multiply them in different way. You can use associative property of multiplication, playing with these numbers around. If I were you, I would first multiply 5 by 2 because the answer will be very easy, 10. And after that, I will multiply 10 by 7. But numbers are so easy that it doesn't matter. Definitely, you can multiply 7 by 5. 35 times 2 is also 70. So I wrote it right there, 70. Now I see, and you see that also, that we have matching bases in both monomials. The base of powers is w. So w to the 1/2 plus 1/3. Basically, what do we do here? Because when we talk about power functions, exponential functions, we are dealing with exponents, you know what, polynomial functions, rational functions. We quite often have in these functions, we have powers, and this is why it is just like exercises in which we just review formulas for exponents. Okay, 70. W. Least common denominator is 6. To convert 1/2 into something carrying 6 in the denominator, I need to increase the top part 3 times, the bottom also. So this is 3/6 equivalent of 1/2. Second is 1/3, same thing. Denominator should be 6. It means it will be 2/6. I'm showing even these details. We have here 2 fractions, 3/6 and 2/6, which are actually 1/2 and 1/3. And this is why it is 70 W to the 5/6 as a result. Answer. Please don't convert this into radical form, even though W to the 5/6 definitely can be converted into radical form. If they ask us about it, will be 70 times W to the 6th root of W to the 5th. Please don't do that, because you need to have a form. I'm going to write this on the top. Y equals kx to the p power. Right here on the top. So far, so good. Can I move to the next problem? Okay. In the next power, we have to solve for x. In other words, they are asking us to solve certain equation. Let's see what kind of equation is offered, and we will try to recognize naming this equation, naming it. So we have 5 to the x to the negative 2nd power equals to 500. Very easy equation. Can you please name that equation?
Exponential.
Guys, can you talk a little bit louder? One more time?
Is it exponential?
Exponential.
Exponential.
It is definitely rational, because how can we rewrite that equation if we like to get rid of that negative exponent? It is 5 over x squared equals to 500. This is a typical rational equation. What do we usually do in rational equations? And this is a part of solution. If you don't do that, your grade will be lowered. Please keep it in your mind. We have here x squared in the denominator of the fraction, which we see in fractional form on the left side. This y immediately exclude bad values for x, because we have x squared downstairs, which means x times x. X should not be equal to 0. If x is 0, this equation will not have any sense. So this is so excluded value, which means the domain for that equation is set R except 0. Sometimes in the textbooks, they are asking us to each time to provide the domain for that type of equations. Because if we do not write any excluded value for any equation, it means domain for that equation is set R. But if it is not set R, you need to mention which numbers cannot be used. Or in this case, if you did not mention that, which actually should be mentioned, you need to solve for x's, and after that, you need to check equation, plugging all your answers for x into original form to see if you are getting true or false statements. But here, if you, in this particular one, if you already demonstrated the value which you are excluding, which cannot be used like x value, it will be enough. You are not obligated to solve and check in these particular problems. Like, for example, in logarithmic equations, we talked about that earlier when we were covering exponential or logarithmic. If your original equation was logarithmic, you have to find values of x, and you are obligated to check every single one because it is a part of solution process. So what would I do here if I were you? Can you see 5 on one side and 500 on the other side?
Yes.
Yes.
Yeah.
I would divide both sides by 5 to lower these numbers. So in this case, it will be 1 over x squared equals to 100. Because 5x squared divided by 5, it is just 1 over x squared. 500 divided by 5 is 100. Because I already took care of the restricted values, I'm not afraid to operate with this x. 1 over x squared equal to 100. You can, if you like, multiply both sides by x squared, divide both sides by 100 after that. You can take independently these easy steps, or if you feel quite strong, you can write down x squared equals to 100. As you understand, we cannot stop right here because we don't need x squared. Should we take square root from both sides?
Yes.
Yep.
And what do you suggest me to write down? I'm waiting.
X
Plus
equals
minus 1 over 10.
1 over 10.
One suggestion, please. Can you, when we discuss these details, can you please talk a little bit louder and I can clearly hear you because we are on huge distance, guys. Okay, yes.
Sorry. Plus minus 1 over 10.
Absolutely correct, because we are solving our rational equation. We already took care of restricted values. In these restrictions, we did not see anything stating that x should be only a positive number. It can be a positive number, it can be a negative number, doesn't matter. We're solving these equations. We need to find all possible values. There is a big difference between process when we solve equations and the other process when we simplify expressions carrying that kind of symbols like we have in these equations. Because when we work with expressions, simplifying expressions, we all the time consider all non-negative results. Can you see how much emphasis I put on this part? We are considering in expressions only non-negative values of any even root, square root, fourth root, sixth root, eighth root. But when we solve equations, we consider all values. And this is why anytime when you take the even root from both sides, like square root, fourth root, six, you need to have plus minus sign. You need to understand the difference. Why? Because according to math requirements, in expressions, we all the time consider only so-called principal values of roots. Keep it in your mind. And again, about principal values of roots, you learned in elementary algebra course, which was taught, you passed that before intermediate algebra course. So just box and we are done with that equation. I went through these easy problems to show you the process. With your permission, can I move to another spot?
Yes,
Yes.
please.
Yes.
Okay. The next spot here is not too big, and it is from 3 to 8. And let's read what we need to do here. In exercises 3 to 8, is the function a power function? If so, write it in the term of f at x equals k times x to the p as a power. Okay, let's do some of these problems. Are you okay with 4 or 6? Just choose one of these problems, number 4 or number 6.
Number 6.
Number what?
6.
6. Okay, so let's write down number 6. So t, this is function named like t, independent variable is s, equals parenthesis 6s to the negative 2. After that, in the second parenthesis, what I see here, it is e s to the negative 3rd power. Six s to the negative 2nd power times e to the s to the negative 3rd power. What should we do here? We need to answer, but you know what? I really recommend you to first simplify these expressions and after that answer that question and indicate the values of k and p matching that form, because you need to get your answer in that particular form, which I wrote on the top. Instead of f at x, I wrote previously, let me box that. I wrote y equal to k times x to the p, but definitely y can be replaced by f at x. So it is same thing like f at x. So this is equivalent of f at x equal k x to the p power. So I'm using the symbol of equivalency. So this is the same thing. Okay, so let's try. T of s. Can you please, ladies and gentlemen, look at both parentheses, and can you please tell me if you have here coefficients?
Yes.
Yes.
And they are?
6 and e.
Absolutely, yes. E here is a letter, but do we have this letter specifically reserved for number E? Like, let's say from Greek's alphabet, we have similar letter pi. Pi is a letter P of Greek's alphabet, but we in math are using this as a number. So definitely we need to multiply 6 by E. Another question which I'm going to address to you is, can I say that in this parenthesis side by side, we have two monomials?
Yes.
Yes.
I think I heard Kyle's voice, right? Saying yes. Yeah?
Yes.
Okay. I would like to keep you very happy, but I cannot lie to you. Probably I will disappoint you. No, they are not monomials. there is a big difference between these expressions when they have negative exponents and when they have positive exponents. If I had here 6x squared times e as in the positive third power, they will be monomials. Because in monomials and in polynomials, we all the time are permitted to have only positive exponents, and these positive exponents should be natural numbers. They cannot even be fractions, even if they are positive fractions, but there will be not monomials. So please be careful. So these are small rational expressions because they have negative powers. Okay, so if you multiply s to the negative second by s to the negative third, what would be the resulting power? S to which power?
Positive 6.
Did you say positive 6?
Yes.
Is it everyone's opinion?
Yes.
Not mine. What happens, what can we do if we multiply powers with same basis?
You add exponents.
Yeah.
We are adding exponents. We do not multiply. This is not power to the power. When we have power to the power, we keep the base, we multiply exponents. When we multiply powers with matching bases, we keep the base, but we add exponents. And if you add -2 and -3, what do you get?
-5.
You are getting -5th power. So you can write this in that form if you like, because it is already kx to the p power. Or if you like, you can write this like 6e. And because to show that it is k, I think it will be nice, again, you cannot use parentheses here, but if I were you, I would use, but I would not use parentheses around x, s to the -5th power. But to say, is it here a power function? Yes, it is. And this time I'm going to write this like k equals to 6e and p is equal to -5. Okay, let me see what we can do here more. There are two quite beautiful, nice problems, actually. At the bottom, again, I'm talking about problems 15 or 16. There are only two problems, so I will leave one for you and one I can solve right now in our class. So which one would you like to solve? Here we need to find the power function through 2 points. We have here 2 given points which belong to the certain power function, and they are given by their coordinates. Because in each of these equations, we see side by side 2 ordered pairs, which both represent certain points. Which one would you like to work with, number 15 or number 16?
Number 15, please. Oh.
15.
15, did you say 15?
Yeah.
Okay, number 15. Again, I'm reading. Find a power function through 2 given points. I am going to name that points like A, let's say 1 and 3, B, which is 4, 13. I would like to choose a certain function to represent a function. In many cases, we use f at x, small case f, capital F at x, doesn't matter. It is your permission, you can use any letter. Would you like to use f, like f at x for that function?
Yeah.
Yes.
Capital F, small case f?
Lowercase.
Okay. So f at x equals, again, I know from this problem that it should be a power function. So I'm going to write it down in its form. So I wrote it down in this form. And now I like to analyze to see what is missing here, what I need to find to declare that, yes, I'm done. I already found that function. What kind of unknowns do we have here, guys? Can you list them? Don't forget, f at x is the name of that function, which means x is the independent variable. What kind of details we need to know to say that, yes, we know that this function is equal to blah, blah, blah? Is k coefficient provided here? Guys, can you look at what you have? You have just 2 points which belong to that function's graph.
No.
Do we know k value here? I heard no, and I agree with that no. So k is first unknown. The next one. Again, x is not an unknown. It is the independent variable because we are using here functions notation, f at x, which means x, which we have inside of parentheses, is our independent variable. So which means we do not know k value, we do not know p value. So we have here 2 unknowns, k and p. And our goal is to find these unknowns. So let's use this to what we have in this problem. We have here 2 points. Let's use these points. So I'm going to get here two actually conditions. What kind? What is the meaning that A, which is the point which belongs to the graph of that function, or this is one of point representing that function, and it has coordinates 1 and comma 3. Does it mean that x value is 1 and at the same time y value is 3?
Yes.
Can I plug into that actually formula for that function, which I'm going to box right now, showing that f at x in this case, is it represented by 3?
Yes.
Is it k times 1, because at this time x is equal to 1, to the p power?
Yeah.
If you have 1 to the p power, what would be its value? 1 to the p power is 1. So which means 3 equals k times 1. In other words, k is equal to 3. And I already found k. Only one unknown is left because now I need to find that p-value easily, because I had 2 points given and I had 2 unknowns in the problem. Number of given points, given conditions equals to number of unknowns. These problems are solvable. Let's do that. I'm going to write the second condition. It's using point B absolutely in the same manner. If we have 4 comma 13, does it mean while x is equal to 4, its corresponding y equals to 13?
Yeah.
Yes.
Let's write it down. So f at x in this case is represented by 13. So it will be k times 4 to the p power. This is what I wrote down. But I know that k value is 3. So 13 equals 3 times 4 to the p power. Agree?
Yeah.
Yeah.
And now let's solve this equation. What do we have here? 13 equals 3 times that power. Can we divide both sides by 3?
Yes.
Let's do that. So it means that we will get 13/3 equal to 4 to the p power. 13/3 equal to 4 to the p power. What kind of equation is that? Okay, I don't want to be extremely naive. This is why I don't want to right now address this to all of you. I'm not saying that people did not recognize, but this is the exponential equation, because 13/3 equal to the power, and base of that power is provided, that is 4. What we do not know, exponent. This is an exponential equation. But here we have quite unattractive numbers on 30. It is one side has 13/3, the other side has 4. If we talk about a good-looking power, so 4, it is, let's say, 1, because it will be 4 to the 0, 4, because it is 4 to the first power, 16, 64, blah, 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 but not 13/3. So you have to use here logs to log both sides. Up to you which logs to use. You can use decimal logs. You can even use log with base 4, but if you need to approximate in your calculator, you do not have the base equal to 4. You have decimal log and you have natural log. We use decimal logs a lot. Let's use natural log, logging both sides. Is it okay with you? But if you like, you can use decimal log, because our final answer will not depend on what kind of log you are using. Do you give me your permission to use natural log?
Yeah, that's
Yeah.
fine.
Yeah.
Yeah.
Okay, I'm using ln. So ln on both sides. Because we probably will be actually approximating to get better looking answer, I will not split log of 13/3 into 2 separate pieces, because it is log of the quotient, which is equal to the difference of 2 logs, which means natural log of 13 minus natural log of 3. If I had to provide exact answer, I probably would, but using calculator, I will leave it alone. So on the other side, on the right, I am going to use logarithmic formula, because you need to remember this formula. So, which means it will be natural log of 13/3, and logging that side, p comes down to the front of natural log of 4. Natural log of 4 is not equal to 0. This is why I can divide right now both sides by natural log of 4, because I'm looking for p-value. Cancel, and you are getting p equals exactly to natural log of 13/3 divided by natural log of 4. If I had to provide exact answer, I would split the top part into natural log of 13 minus natural log of 3, keeping natural log of 4 downstairs, but not here. Grab your calculators and carefully, using all required parentheses, enter natural log. It comes already with open parentheses, entering 13 divided by 3, close parentheses. Don't forget to close, because if you do not close parentheses, it will change this expression to absolutely different. After that, again, division sign, because you need to divide by natural log of 4, also in parentheses. Natural log of 13/3 divided by natural log of 4, and push enter. And let's approximate having, let's say, 3 digits after decimal point, approximately 1.05. And after that, I have 77. So I'm increasing this to 8. Voila. Now I have here approximated value for P. You can see we found that K value quite easily. Here we were obligated to work a little bit harder to find the K value. So, the P value, excuse me. And finally, write the answer. But because we already approximated P value, I would not use regular equal sign, because sometimes, unfortunately, in the textbooks, I see that, and which makes me very angry, actually, because textbooks should not afford this kind of mistakes. Anytime when you approximate it, you are not permitted to use regular equal sign anymore, only approximated sign. So it will be K, which is 3, times X to the P power, which is 1.058. And this is your final answer. Questions about this problem which we just solved?
No.
No.
Thank you.
Don't think so.
I will move to the next page. And I would like to talk about limits again. Because here in this chapter, in this section, we actively will be using the notation of the limit. I'm going to create right now my own example, which will help you definitely. Okay, let's say we have limit x approaching 0 of 1, let's say, over x squared. And example number 2, we have limit x approaching, let's say, positive infinity of the same thing, 1 over x squared. Two examples, very similar, but at the same time, huge difference. In first case, x is approaching 0. In the second, x is approaching positive infinity. What about these limits? Even if x is approaching to 0, we perfectly understand that it cannot reach 0 itself, because we have 1 over x squared. In this case, if 0 is reached, we are going to have downstairs in this fraction 0 squared, which is 0. We cannot divide by 0, which means this meaning of that math symbols tells us that x can be approaching 0. It can be approaching even from one side or the other side. Let's say here we are assuming that it is coming to 0 from the right, which means staying positive, greater than 0. What happens in this case? Let's say we already have x equal to 1. 1 squared is 1. Result of that fraction will be 1 over 1 will be 1. Let's say it is equal to 1/2, because it is again moving to 0, closer and closer. 1/2. 1/2 squared is 1/4. 1 divided by 1/4, it is already 4. 1/3. Square of that, 1/9. 1 divided by this number will be giving us 9. So which was, comparing just these values, we first got 1, and after that we got 4, and after that we got, let's say, 9. Let's say x is equal to 10. So it will be here. Oh, I said 10, I really apologize. 1/10. 1/10 squared is 100. If we divide by 100, are we going to have 100? You
Yes,
can
yeah.
see the result of that fraction is constantly, rapidly actually increasing. All the time when you see in these textbooks that type of notation, definitely, again, let's say we are again assuming we can even downstairs write a small symbol next to 0 to showing that we are doing this using only positive values. Look what I wrote, but here even doesn't matter because we have even power of x. Even if x is approaching 0 from the left side, negative number squared will be positive. It will have the same answer. I just wanted to specify these details. This will be your answer. This limit is equal to infinity. This is equal to infinity. And the second case is absolutely different. Here is x approaching to infinity, which means the x value is rapidly changing, becoming greater and greater and greater with each move to the right. If we start plugging numbers here, let's say x is equal to 1, it will be 1. X is equal to 2, it will be already 1/4. X is equal to 5, let's say, it will be 1/25. It will be constantly, that value of that fraction will be going smaller, 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 with each x becoming greater and greater and greater. And this is what we have. If it is roughly 1/infinity, the limit is 0. And it doesn't matter if it is 1/positive infinity or 1/negative infinity, that limit all the time will be equal to 0. You can see from one hand, expressions are the same, 1/x², but two limits are absolutely having different values. I will be putting a lot of emphasis tomorrow on limits and show more problems because we will be actively using limits, and I will teach you certain secrets how to deal with limits, which should help you a lot in your calculus class. Try not to miss tomorrow's lecture, and please, again, try to take really good notes because these notes can help you a lot in your calculus class if you're planning to take this course, because in calculus class, limits can cause quite big headache because, for example, derivatives are also limits, all type of derivatives. With your permission, can I finish today's class? Please, again, do all homework assignments. I will assign you only one more online quiz. So please try not to miss any of lectures because it will be very important to understand this material. Can I tell you guys that we are done?
Yeah.
Yeah.
Thank you very much. Have a nice, beautiful day. I'm extremely proud of people who got very good looking grades for the test. And I really recommend others who did not get attractive grade to be seriously prepared for the final, because it is really important for you. In nowadays we have such a crazy semester, which is very difficult for everyone. It is so important to pass this class. Okay, everyone have a nice, beautiful day. Goodbye.
Bye-bye. Thank you.
You're welcome. Goodbye.